discussing internal wiring in a house, in a household circuit. So we are discussing what is known as the ring circuit for household wiring. The electricity company drops two wires when they give a connection to a household. One wire will be the 220 volt live wire and the other wire will be the 0 volt neutral wire. And I was mentioning in the previous class, just in terms of transmission, these two wires you will find are the wires that come using your electricity poles to the household. So you can go outside and have a look wherever there are electricity poles. You will see these two wires. But obviously, they will not be color coded in any way when they are put across electrical poles. So they are just basically aluminum cables, twisted aluminum cables. And the reason we use aluminum is because it's relatively cheap in comparison to, let's say, something like steel, and aluminum is also lighter than steel, so it's easier to work with aluminum, and the conductivity of aluminum is comparable to that of anything else. It will be much better to use copper in terms of the conductivity, but the problem is copper is very expensive. And the other thing is that aluminum has another advantage. You might have studied it in chemistry, which is that aluminum, when exposed to atmosphere, quickly forms a layer of aluminum oxide on the surface, and that aluminum oxide then prevents further corrosion. So aluminum is something that is durable. Aluminum wiring does not need to be replaced for a very long period of time, which is not going to be the case with steel or with even copper. So transmission wires are aluminum. Household wires, however, are copper. So when you do the wiring inside the house, the electrician will typically run a wire around your house. And this I'm just taking one room of the house into consideration. The complexity increases obviously if you have multiple rooms and so on. But the basic idea is this. So they run a insulated copper wire within the household. Insulated copper wire because lesser amount of copper is required, and also it is insulated, it's covered with plastic, so you don't have so much the problem of corrosion and so on. And of course, resistance is far lower for copper. And the neutral wire also will be done in a similar manner. They usually have some, when they are building the house itself, they will put some conduit wires within the walls, and they will lay within the conduit wire some kind of a rope or something, and later when they do the wiring, they will just tie the wire to the rope and they will pull it through. So that's how there is some skill involved over there, and electricians are good at doing that kind of a thing. So you have one live wire running around the house inside a insulated PVC pipe or CPVC pipe, and you have another neutral wire going around the house. Okay, so now it's fine. Now how do we connect any household appliances to this setup? So basically, if you want to install a device in your house, then you take one wire from the live wire and one wire from the neutral. It's called a tap. So you take one connection from the live and one connection from the neutral, and this will be connected. Let's say we'll start with a plug point, say for example. So you have a plug point, and these two will be connected to that. Now, if you want to connect any device to this plug point, like let's say a mobile charger or something like that, then you have this plug which goes into that. This should be a little wider. Okay, and then this will go to the device, whatever it is that you want to connect it to. So these two will get plugged into this. So there will be one live, one wire that is connected through. and therefore a current can now flow through the system when you put a switch. Now a small discussion ensued in this. Obviously you don't want these points to be connected permanently uh, on. Okay, so there is a safety device that we use. Say for example, if you have a switch like this, which into which you connect the point, you also obviously have a switch along with this. Uh, that is on and off. What are the symbols? It's a line and a dot, is it? This is on and this is off. Is it something like that?
Yeah.
Okay, I'll just write it anyway over here, on and off, the kind of two-way switches that we have at home. So what is the function of the switch, to see it in a simpler manner, is that basically the switch helps to control the current that is coming into the circuit. So we were asking the question, if a switch has to be put in the circuit, um, you can put a switch, sorry, you can put a switch in the live, or you can also put it in the neutral. Both are possible. In fact, both can also be done. Now it's useless to put a switch on both, so we put it only on one of them. Now the question arises, which one does it make more sense to put a switch on, and why? Okay, so we have discussed this already, so I won't undergo the discussion again, but I'll just mention it. If the switch is put on the neutral, let's say, okay, so if you put the switch on the neutral wire, then of course when you put in a plug in a device and you switch it, and you run the device, there is no current in it, so the device will not work. So as far as controlling the current in the circuit is concerned, it will work, but there is a small problem, and the problem has got to do with safety. The Although the circuit is broken and there is no current flowing through this circuit, the problem is that if you put a switch on the neutral wire, this point on the upper side is going to be live all the time, which means it's at 220 volts. And if by chance some child meddles with this circuit, okay, and believe me, I have done things like that. I once put a compass into the plug point. I thought I was making a solenoid. I got the idea of how to make a solenoid. So I took a copper wire, I took a compass, I wound the copper wire around the compass, and I thought I'll just have to put the two wires into the two sockets and switch it on, and I'll get a solenoid, or basically I'll get an electromagnet. Um, Luckily for me, my house had a kind of an device which is called as an MCB. We will discuss that a little later. Basically, it's a fuse system, and what happens is, if there is a large amount of current coming through the any point, then the fuse blows, and the electricity is cut off to the entire house, and MCBs work very fast. Okay, so luckily I didn't get electrocuted, but children are apt to do things like that. And also I had mentioned last class that while holding the plug points itself, if they are poorly designed ones, you may be touching one of the metal parts, the pins that go into the sockets, and if one of them happens to be live while the switch is on, then if you put the socket into it, you can get an electric shock. I will define what is an electric shock also. So therefore this is not a good idea. It will cut the electricity in the circuit or control the electricity in the circuit using the switch, but one of the points will always be live. So therefore it's usually done in this manner, that the switch is put on the live wire. Okay, so when the switch is on the live wire, then you don't have the problem that I mentioned earlier. So now when you switch off the switch, if the switch is in the off position, then there is no current coming, no live among these two sockets. So accidents will not happen in that manner. So that is the reason why we put the switch on the live wire and not the neutral wire. Now we can discuss about the dangers of electrocution, okay, and what is the step that we undertake to do that. The wires that we use for electrical appliances, so usually you have a plug point and then you have a cable that is running through here, okay, and inside this cable also you have the live wire going through and the neutral wire going through, okay. So it's insulated, but the live and neutral wire are going through this, and it's going to some kind of a device. Can you suggest some device that is simple to draw and illustrate? Some kind of a household device. I think an electric iron works very well. So okay, I'll use the electric iron example. That's a good one. I'm just drawing it in a sort of rough and ready manner. Don't take the device too seriously. It looks like a spaceship, but it's okay. So basically when you connect the live and the neutral inside an electric iron, the electric iron has a heating element. Basically it's a wire that has a large amount of resistance, and obviously when you switch it on, this heats up. So this element heats up, and then you press clothes using this, okay. Mind you, the whole thing is insulated, so you don't have any exposure to these wires outside. Now the problem is that electrical devices, something like an electric iron, say for example, is used for a very long period of time, and there is some wear and tear on the insulation that can happen, okay, which means that the plastic cover that is covering the live wire or the neutral wire, whatever it may be, gets worn out over time, and the internal copper wire can come in touch with the metal body of the appliance, okay. So when the metal body of the appliance is in contact with the live wire, that is not the intention. See, the live wire is supposed to be in contact with the heating element, and the heating element is the one that is responsible for just heating up the bottom plate. But now what happens is that the live wire is in contact with the body somewhere, let's say like over here. And what that does is it makes the entire body, if it's not made of plastic obviously, the metal parts become live, okay. And then somebody tries to touch or handle the device, and what will happen is that they will get an electric shock. And they'll get an electric shock because when you touch a live wire and your feet are in contact with the ground. So to show it somewhere on the side, basically let's say there's a table and there is the electric iron and it is live because of a exposed wire. Now when you touch this, okay, this point where you contact is at 220 volts, okay, and you are touching the ground which is at 0 volts. So what is going to happen is that there is going to be an electric current that's going to flow through your system, and this is electric current which is at a very high voltage. The amount of current flowing through your body may be small, but the potential is very high. Remember, 220 volts means 220 joules per coulomb. All right, and if that amount of energy, electrical energy, passes through your system, through your biological system, depending upon which part it passes through, it can give you severe burns, a bad electric shock, which which can even lead to fatal consequences. Like if it passes through your heart, if it passes through some other vital organ, right? There will be enormous amount of heating up because our body is a resistor, so burns are possible, and obviously it creates a dangerous situation. So how can this be avoided? Okay, this can be avoided by another system that is created for this, and this is entirely internal. Okay, so the electricity company does not provide this, but houses are expected to install this safety device. And what is that safety device? Is another wire called the earth wire. Okay, so there is an earth wire that also goes around the house, and that's also a copper wire. It's usually thicker than the other two wires, and I'll tell you the reason why, or you can guess the reason why once I have explained what is the role of this earth. Okay, mind you, anywhere where there are junctions of these wires, they are not touching one another. Okay, they are insulated wires, so they are independent. So now what they do is, you also pull a wire from the earth wire that is connected to the third point that you all might have seen in larger electrical circuits. So like say for example, a laptop charging device, mobile charging device, they will have only the live and the neutral. Okay, but for something like a refrigerator, something like a geyser, something like the electric iron, microwave, ovens and so on, you will have a third point over here which is usually larger than these two live and neutral points. Okay, now that uh, earth wire, mind you guys, wherever you are not able to follow something, please ask. Okay, so that live wire will obviously now have a third point over here, a larger one, to which it will get plugged into inside this one. Okay, and that wire also goes through the insulated cover, and that wire is kept in contact with any metallic parts of the device. Okay, so listen to what I'm saying. There is an earth wire that is also part of the ring circuit, household wiring ring circuit. That wire is connected to some plug points in which there is a danger of electrocution, and that wire is then connected through the thicker point to the metallic part of any device's body. Okay, so now what happens? As long as there is no malfunction, as long as the live wire is not exposed, the insulation doesn't go away, there is absolutely no problem. The live wire has no use whatsoever. The moment the insulation for the live or the neutral is compromised and there is a contact to the metallic part of the body where the user might touch it, what is going to happen is that the earth wire, which is at zero potential. Okay, so one more thing is that this earth wire is normally given a zero potential. This wire will be buried underground somewhere outside the house. Okay, they dig a pit and they put some salt and charcoal and all that I'll explain a little later, but basically this is at zero voltage. Okay, and the earth, for the same reason that you might get electrocuted, has got enormous capacity to accept electricity. All right, so what will happen is that when the live wire gets in contact with the metal body is in contact with the earth will pull a huge amount of current through the circuit. Okay, and when that happens, there is a device called the fuse which will protect the user from an electrocution. So now the question is, what is the fuse? How does the fuse prevent electrocution from happening? That we don't have time to discuss today. We will talk about it in the next class.